Alright, so it's wide open. What do you want to talk about? You want to talk about something like homework, specific, if you have a general question, how the hell does that work? Why the hell does that work? Yeah.
For the first one, we're not solving, but where it says find inverse f of x. For graphing it, you just want us to swap the x and y, like you don't want us to actually algebraically solve it.
So that one's algebraic. First thing I want you to do is find f inverse. So that's where you switch the x and y. And then graph both of them.
So I was just, because it just said graph both, so I don't know if you just wanted us to switch the x and y coordinates and do it, or just...
Oh, yeah. I'll tell you this, I'll do this straight up. This is not a problem I put on the practice test, but you know I'm going to put a problem like this. I'm going to give you a function, a picture, a graph. I'm going to say, plot the inverse of that. And actually, first I'll ask you, why does an inverse exist?
Because it's a horizontal line.
I love it. Passes a horizontal line test. So it's what?
1 to 1.
1 to 1. Cool, man. Stereotype, that's right up front. So this is 1 to 1, so therefore an inverse should exist. And visually, what should happen with the inverse?
Switch the x and y values.
Okay, good. Right? You can switch the x and y values, but once you've plotted it, once you've done that, what should you see visually? What should
Straight across the y.
Yeah, your mirror would be at the y equals x line, right? So if I just want to do like a quick, it should look something like that, maybe, right? I just want to do a quick ugly. That's really ugly. So hopefully once you've turned your points around, it'll be really nice. You can see that. But how do you officially verify inverses? Verify f and g. And some of you guys have trouble listening to homework. It's sort of like, I always give examples from my lower level classes, but when I teach my Math 88 students, before we do solving equations, they have to check to see if 4 is a solution. Right? And so somebody knows how to solve this already, so they solve it, but they have to say, no, it's wrong. It's a check to see if it's a solution. You've got to put a 4 in there and see if it's true. So when they say verify that these two are inverses of each other, you don't take one and find the inverse. How do you verify that they're inverses?
Equal to x.
Plug one into the other.
Yeah, plug one into the other, and then they should equal to x. So you plug G into F, or F into G. And tell you honestly, the nice thing is if one way works, the other way must work, which is nifty. So you just have to really do it one way. You guys with me? So be really careful. If I say verify that they're inverses, plug one into the other one, and show that it does equal x. Because that would mean f and g effectively cancel, which is what inverses should do. Cool. So that's our first problem on the practice test.
So when you plug g of x into x, it should equal 0?
Exactly. Not 0, they should equal x. Yeah. And f and g will cancel each other, but that doesn't mean they'll become 0. G does something to x. F undoes what he did, so you should end up back at x. So cool. So really the second question where I say what's something like that, I can't remember.
Yeah, where it was x minus
3, yeah. What should that be? Yeah, what did f and f inverse do with each other? Cancel out, so then you get x minus 3. Right? It's exactly the same thing as what's the cube root of x minus 3 cubed. Yeah, what did the cube root and the cube do? Cancel, because they are inverse functions. Right? Opposite is acceptable. But I don't tell you what the hell the functions are, but maybe they are cube and cube root. Maybe they're 5 and 5th root. Maybe they're 1 over x and 1 over x, because it's its own inverse. Right? Maybe there's some freaky function we don't even know yet. I don't even need to know what it is. I just need to know that this has an inverse and there it is, so they will kill each other. Just like this specific example was. Cool. Eternally hopeful. Any other questions? From anything? Yeah.
Can we go over number 100 from 3-4?
Whoa. Okay. threw me off. I was like, how long did it make that practical? Oh yeah, good. So we'll read that over. This is page 262, number 100. Yeah, hopefully enough of you have your books. Looks like several of you don't. So it basically says a rectangular piece of partial of land has an area of 5,000 square feet. The diagonal between opposite corners is measured to be 10 feet longer, and they were really, really nice, and I will not be this nice. And they drew the picture for you. Okay, you guys with me? So this is supposed to have an area of 5,000 square feet. The diagonal is 10 feet longer than the length of it. What are the dimensions of the land rounded to the nearest foot? I like it. So they ask you about the area. They give you this. They ask you about the dimensions of it, but they give us this picture here, and they tell us what the area is numerically. So what's missing to tie those two things together? So I've got visually what's going on, but what's the area going to be in this case? Don't tell me 5,000. And what's y? Yeah, the missing piece here, right? So know the area is x times y. Of course, the problem there is there's two variables in there. I don't like two variables in there. I want one variable to work with, right?
So would y then equal 5,000 over x?
How would you... Now, what you want... Now you got to be careful about circular reasoning. If I solve this for y and then plug it back into that, and this is the only equation I have to work with. You with me? So if I solve it and then plug it back into itself, I'm going to get circular reasoning. It's going to be true by default. I haven't used what they've told that relationship there at all. So do you guys see that? This is almost always what happens. They tell me something directly, and then they ask me something. Now in this case, they helped me out a little bit. They gave me the picture, but they asked me about the dimensions, given that they have some relationship. I know the area is x times y. I'm missing what y is to help me out. Can I figure out what y is from that picture? What's true about that? Well, I know it's a rectangle, so what kind of triangle is in there?
A right triangle.
Right triangle, because it's got a nice 90-degree angle. So what's true about the sides?
X squared. Y squared equals X squared.
I love it. So I know that x squared plus y squared, the two legs, must equal the square of the hypotenuse. But I really want you guys to see the problem. The problem is my basic equation that I want to work with has too many freaking variables in it. I need it dependent on just one variable, and then I can look and see if it's quadratic and find the vertex and all that kind of business.
Can you just solve, subtract the x squared and then...
Yeah, now that I've got a second relationship between y and x, this is a system of equations. I can solve one for y and plug it in the other one. I'd probably rather do like you were saying earlier. What's y from this guy? What do I know here? What's y equal to?
Y equals 5,000 over x.
Good. So now we can finally do something with that. We can plug that into here.
Okay, I got that much. Now, that's where I got messed up.
Let me just stop there for a minute because we've done a lot. I want to make sure you guys are semi with me. What's most important, obviously, always is can you do this yourself without me guiding you, right?
Well, I got up to that point by myself.
I love it.
I got confused.
And you always just write down whatever if they tell you area is something, you figure out what the equation is. If you're missing from the picture, you're missing something, label it with some new variable and go, shit, I got to figure out what that thing is. So I can use it, right? So now all you have to do now is, this doesn't, it's so easy for me to say all you have to do. You just got to plug that in there. And now you have only one variable in that equation. You only have x in that equation. And that we can handle. It's not going to be necessarily pretty. throw that in there, what do you get? So you throw in y is 5,000 over x. And now you just have to square that. Okay, good. So you get x squared plus
25 billion.
simply a 2, 5, and then 0, 0, 0, 0, 0, 0.
Yeah, 6 zeros.
That's cool. Over x squared, right? Equals, what's this?
X squared plus 20 plus 1.
Yeah, it's not x squared plus 100, right? Be careful when you square, you gotta FOIL that thing out, right? That's the worst thing. You set everything up beautifully, you do all the math right, except for that one thing. Somebody thinks that's x squared plus 100. Throws a whole thing to crap. You get land with imaginary sides. That is what I want to go to that far. I want to go to wherever that is and see what that looks like. All right, and now, holy crap. All right, one nice thing is, what's the very, very nice thing that happens on both sides here?
You can subtract x squared.
Yeah, the x squares go away. And then I can multiply the x squared up. Now, thankfully, what symbol is on this problem? Because the only function, the only kind of thing that we can handle by hand to maximize or minimize is what? What picture can we find the maximum or the minimum? What graph? What image? Parabola. I love it. Sweet. Because we got the shortcut. What's the shortcut for finding the vertex of a parabola? X equals
Negative b over
negative b over 2a. Are we going to end up with a parabola here?
Yeah.
You sure? Probably the way I asked that gives it away. When you multiply by x squared, right? And then the next step, get that x squared the hell out of the bottom. What's going to happen here? X cubed shit. Right? That's why they have what symbol sitting next to this problem for the book full out there. Well, calculator symbol is sweet because it is a problem I cannot do by hand yet. Calculus will be able to tear the thing up. Here we can't do anything with it. It tears us up. So we have 25 million equals 20x cubed plus 100x squared. You just multiply the x squared up. Is that cool? So to do this in the calculator, you can just subtract it over, graph this thing. You can divide by 20. You see that? You can divide everything by 20. That's not a bad idea. Make everything smaller. So you'll end up with x cubed plus 5x squared minus 125 0, 0, 0, 0.
Yeah, 4 zeros.
Cool. Equals 0. Now, a lot of you guys either think that things change, or it's been a while since you last took algebra, or something. But a lot of us are just not able to do these 3 steps. Mess up somewhere, you're not sure what to do. This should not be a big deal at all. This problem, up to this point, if you have this, you should be able to get there relatively easily.
That one just confused, because as soon as I saw 25 billion come up, I just assumed I had done something wrong.
No,
Stopped and figured it out and asked.
Yeah, you got to consider this is probably a large. I mean, the area is 5,000 square feet. So in the mathematics, I can expect squares of that showing up, which is going to be huge. So it's fine. Yeah, so we're talking about huge tracts of land. No, maybe not. And so you should expect some big number to show up. Don't think that you're wrong. So let's see, what does this thing look like? Let's do this real quick. Because you know I'm going to give you at least 1, if not 2, calculator problems. Please wait. Okay. Color scheme has been changed. What? Holy crap. Somebody's been playing a resolution here. It's crazy. Alright. So now if we plug this in. Is everybody cool with, semi-cool with, you guys see what? You could, so you could bring this over, and now it's a question of doing what in the calculator. If I get this equal to 0, when I throw this in the calculator, the nice thing is I do exactly that. I want it to find the zeros. You can leave it here and put that into y1, put that into y2, and find the intersections of those. Which tell you, obviously, honestly, is my preferred way. Let's do it the other way. Let's see, x cubed plus y squared. Let's see, minus 1, 2, 5, 0, 0, 0, 0. Okay, cool. Okay, that's good. Yeah. So, what is this guy's y-intercept? -1. Yeah, yeah. So, I mean, if I graph this thing, in fact, my scale is really freaky. So, even if you zoom 6, you're probably not going to see anything. So, let's try zoom fit. Let's see how it does. Zoom. Holy crap, I got a lot of stuff on this. There, zoom fit should be the last one in most of you guys' options. That's where the calculator tries to fit. Yeah, what we try to do this thing, we try to maximize this thing. Let me see. Yeah, that's good. This is all negative territory here, right? Yeah. So I'm going to have so looking at the original thing here, what's the largest? Let's see. If x was 5,000, y would be 1. So I'm thinking the answer should be somewhere in the middle. Now, why do you think I'm kind of worried about what we got so far?
Because it's all negative and it's not a parabola.
Well, no, it's a cube, so it's not going to be a parabola.
Yes, it's okay to not be a parabola. But actually, something else here too, it looks like they want me to find the maximum of this. But it looks like there won't be a maximum because it's got that little flat piece in the middle. But it is possible that there is like a little maximum in there. Maybe it's hiding something. So let me try that, and if that doesn't work, we'll have to look a little deeper.
Aren't we just finding the x-intercept to solve it?
Oh, that's right. So here I am thinking that I'm doing the other class. All right, let's go to the window. Now, does it make sense what I was just doing a second ago? If x were 5,000, y would be about 1. So the answer should be somewhere between 0 and 5,000. And if I look at my graph, where does it look like it's going to hit the x-axis? Yeah, it looks like it's going to hit it right about 10. So let's pick this thing up. Let's say, actually this is y-max is way the hell down. That's crazy. So let's do this. Let's go back to zoom 6. Back to normal. Now let's go to zoom out. See if we can catch it. We should be able to see something eventually. We have to zoom out again. Zoom out. There. Yay. Alright, cool. Sweet. So now we just have to find that y-intercept. So yeah, I forgot we set it up to equal 0. We're just trying to figure out how to find the x-intercept. So how do I find that x-intercept? What's really weird about that guy is it looks like the line is straight up and down. So this has got such a huge slope there. So it's just rising through that point so quickly. Let's see what we can do here. I'll try to calculate the 0. See how long it takes to get there. That's insane. Let's change our window a little bit. Let's try to zoom in on this piece. Actually, we'll do my favorite thing, which is zoom box. There we are. Okay. So if I do a zoom box right around the point that I'm interested in, this is why this is my favorite thing to do, is because I can just get it to go right where I want it to go. It's still like a straight line, it's crazy. So if I do calc 0, oops, go away from it. Now watch, this is because this thing is so quickly rising. And watch my y values as they move around. Watch how much they change by. It's negative 5,000 right now. Now it's positive 6,000. You with me? So the first thing it asks me for is a left bound. So if I hit the left, now I know that 0 is right in between those two. So if I hit it a couple times over, that's definitely on the left of it. So I've just gone, it's way the hell off the screen, but this thing is rising so fast that I can't really see the cursor bouncing all up and down. So if I hit the left arrow a couple times, I'm definitely on the left side of it. Enter. Now if I go up to the positive territory and the right arrow once, I'm on the right side of it. Enter. And my arrows show me, yeah, I'm good. I'm looking right where I should be. I'm looking between those two arrows, and the answer should be between those two. And then my guess, the closest I can get, is there. That's the closest I get to 0. There we go. 106.08. So it looks like X should be 106.08. And then you can figure out Y by just plugging that in. Alright, so that was disgusting because the graph was just so insanely quickly rising, it was hard to really pinpoint where that was happening. I would probably give you a graph that was a little more gentle, so it's easier to see what left and right are. I mean, here it's just straight up and down, what's left and right. Okay, and what else they ask for? They ask for the dimensions. What are the dimensions? That's all I want. Cool. So you got X, then you can plug it in and get what Y would be.
47-ish, 47.16.
Alright, so when you plug that in, you get about 47 point something feet. Cool. I like it. And how could you check yourself?
By plugging it in.
Multiply those, you should get 5,000. Of course, that won't be really checked because that's how we got that. You can plug it in the other guy and make sure it works. This guy here. That's how you can check yourself. Use the other equation to check yourself. Yep.
Can you do 76 from 3 to 1?
Oh, yeah. All right, good. This is one I definitely expect questions on. Now, the problem is, just to let you know, the problem is if you did all this by hand, and what you couldn't do was see what the hell is going on the calculator, or if you feel you've made a mistake during a test, you just come up and ask me, and I'll at least tell you if you're on the right track or not, or give you a little hint about the calculator. But what I probably wouldn't do is to give you one this insane. Now, this rain gutter problem is like a classic problem. You see this all the time. So you have it's crazy. 30-inch wide rectangular metal sheet. And they bend up the sides. So they choose like by the same amount. Is that cool? So this is pre-bend. This is the picture they don't give you. So when you bend up the sides, you'll end up with the picture they have in there that they can definitely draw better than I can. Let me give it a try.
What number is this?
76. 3-1.
Alright, so I know it used to be 30 across all the way. It was 30. That was all 30. What is this little piece here now?
30 minus X.
30 minus 2x, exactly, because it bends it up on both sides. So this is 30 minus 2x. Once you've done enough of these kind of problems where they say you start with a piece of sheet metal and you bend it in all these different directions, you very often get like that 30 minus 2x thing. Like normally you see like making a pizza box, you cut out the corners and then you fold it up. But again, you get the same idea of x, x, so each side changes by minus 2x. You see that normal thing happen, a pattern. And they don't tell us, they don't need to tell us that. They don't tell us how long the damn thing is, but we don't care. So I really didn't have to draw it like all 3D, which I really technically didn't. I tried. All I care about is the cross-sectional area. So that's good. If I look at it straight on, oh, something bad happened. My God. This will be 30 minus 2x. These are the sides we bent up. There's your minus 2x, x on each side. What's the area of this?
X times 30 minus 2.
I love it. It doesn't matter that it has no top, right? Because once the water gets there, it's going to flow over anyway. So we're still talking about the same cross-sectional area of water. So this will be x times 30 minus 2x. Now let me stop right there. Yes, sir.
The 30, so shouldn't the 30 be on the other side?
No, all I did was I bent up the sides, so I just put this there.
Yeah, well, wouldn't it still be 30 if you bend it?
Yeah, that should be there. You're right. Thank you. Yeah, cool. So what they didn't tell me was this piece, and I don't need that piece. So is everybody cool with how I got to that? The big deal there is they give you the whole 3D image when really all you care about is the area. So what would probably trip people up is worrying about what that length is. And you might say, well, that's y, and then you get all this weird shit. But all I care about is the area. What's really nice about that equation? What type of function is it?
Quadratic.
Quadratic, which is a parabola. If I graph it, which I know exactly how to get its maximum. All right? Why will this thing have a maximum?
Because it can't be negative, you can't have a negative area.
Well, that's not why this function would give us a maximum. If I multiply this in, I get 30x minus 2x squared. Why does it have a max instead of a min? Because the parabola has to point down. It's got a minus in front of the x squared. So it's got to be a down parabola, so it will have a max. Thank God. So I want this to hold the most water, right? That's what I want this gutter to do before it goes sloshing over. So I want to maximize that area. And so how now your whole focus, so one part of these word problems is setting up the equation. The other part is now analyzing that equation. If I don't say you can use a calculator, it must be quadratic. It must be something parabolic. You must be able to find the vertex. How do I find this guy's vertex? Yeah, exactly. So find the vertex, the shortcut, negative b over 2a. And this is where you got to be really careful. What's b, what's a?
30 is b and 2 is a.
This is out of order, right? So it should be, if you want to, like that. ax squared plus bx plus c. So be really careful. Just because the number comes second doesn't suddenly make it b. So b here is 30. A here is negative 2.
So 34th.
Which is 15 halves, which is
7.5.
7.5. I like it. So 7.5, what was it, inches probably. So that's part B. Find the value of x that maximizes this area.
So what would be the function? Would it just be like f of x equals x?
This is the function right there. And if we wanted to, we can further define it as a of x, because there is just one variable in there. So this is a little bit better than that last one we did. The last one had two variables in there. We had to take a minute just to figure out how to replace one of them. Here, I start off with one variable, kick ass, so they can start attacking it right away. And then part C is just, what is that area? Yeah, just plug it into the area equation, right? How do you find the area? You probably use the area function. Just plug that back in. Cool. Please, dear God, if you get negative length required for something, say something about that. Don't just give it to me like that. If you can't see why it's negative, just say, I know it should be negative, but I don't see why not. Say something. Right? Makes me feel a little better when you realize it can't be that. That's some weird shit. Not sure what that would be. Raiders. Alright. So any other questions from practice test or from homework? Yeah.
So, can you do 25 on 4
3, 6?
Yeah.
So in general, when I ask you to factor something and the powers are higher than normal, like higher than a square or a cube, you should expect there to maybe be a next step. So here, this is after section 3.5, which is our complex number section. So now I have to expect complex answers to be a part of some of my problems. Yes, sir? Oh, thank you. I am always cool with you guys reminding me about this thing. Okay. I forgot which one we were doing. Which one is it?
25.
25. Oh, wait. 16x to the 4th. This is section 3.6. What? So this is the one, right?
Yeah.
Okay. So the very first step, hopefully, is not that big of a deal. It's only got two terms, so what could it be?
Difference of squares.
Squares or cubes. It's definitely not cubes. It's got to be squares. Everything's something to cut in half. So what's the first step?
4x squared minus 9. 4x squared plus 9.
Yeah, first step is easy as hell. Just cut everything in half, plus minus. So difference of squares, no matter how loaded with stuff it is always a thank God problem. Get rid of one half, minus plus. Or thank whatever deity you want to thank. This guy's always got a next step to it, no matter what level math you're in. But this guy now has a next step to it, even though normally doesn't before. What's this guy's next step? Again, he's a difference of squares.
2x minus 3, 2x plus 3.
Yeah, either way, I like it. So this guy is really the same exact idea, except the only thing that can make it come out positive at the end in the middle is to add an I in there.
I messed up on the first part, so shit now.
You guys cool with that? You guys see that? Yeah.
So whenever there's a positive for like squares, we always add the I for
the next step? Yeah. Yep. Even if technically it's not, like if I had x squared, I think I had one in the test, like x squared plus 11. How would you factor that? Don't freak out.
X
How do you get 9? How did you get 9? What did you do to 81?
square root.
Square rooted, okay? Do it again.
x plus root 11 I.
I like it. And x minus. It's just the I is normally put out front, so I itself is freaky. Think about square root of I. Okay, now stop thinking about it. I like to do something like that for a bonus, though, just to let you give you a little clue. It's not going to be that, or something like that. Is that cool? Yes, sir.
Can we never do it?
Yeah, and real quick, if I solve this piece, can't I add 9, divide by 4, is that cool? And take a square root, so I get plus or minus 3 halves, I mean, that's no big deal. But if you solve this piece, and that's of course where you see 3 halves, is that cool? If you solve the other piece, you'll end up with x squared equals negative 9 over 4, and that of course is where my I comes in, 3i over 2, 3i over 2, you guys see that? So that's the connection between solving it and the factorization of it. Okay. Some of you guys look really sleepy and you're trying to look like you're, yes. Alright. Pre-calc does that to people. So which section, I'm sorry, did you?
The
Practice test.
number 2.
Number 2.
Yeah.
So that was the example I was giving that looked like this here. Believe it or not, it's exactly the same problem, just a little more specific. Because for this one, f would be cubed, and f inverse would be cube root. And what, of course, do these two do to each other? Cancel. So that's way too specific. In general, f inverse of f, they will always cancel, leaving you with whatever's on the inside.
So you just plug it in for x?
No, your answer is that, is the x minus 3.
So the answer to that problem is the x minus 3.
Exactly. So think about it this way. F, now go with me. F does something to this, right? What does it do? I don't have a freaking clue. I don't even know what F is. Could be some weird shit that I don't even know. But I apply its inverse. So whatever F did to this, F inverse undoes that. So it goes right back to where it started, which was x minus 3. Is that cool?
Oh, you have the answer, just x minus 3.
Exactly. I would hope to see maybe even, do something like that. Yeah.
You do number 3?
Does that make sense back there?
Yeah.
Okay. Number 3. Oh, yeah. What's number 3's end behavior? How do you tell?
It's a graphing kind of.
No? Well, how do you mean?
Well, it's got an even root.
I like it. It's got an even power at the end. I'm going to say that even a different way, because it's not because that square there. What would the overall highest power be?
4.
Yeah, this is like basically x, this is basically x, this is basically x squared. So at x to the 4th, and of course that would look like, on the end, so like.
Parallel.
Yes. Yes.
So, is that all you would want us to write for the same with the end here?
Yeah, a little explanation as to where, and then that quick picture. That's all you got to do. You don't have to give me infinities and all that. I know the book likes to do all that. When x goes to infinity, just give me the picture, right? Shoots off positive infinity on both sides. Picture gives me that real quick. A little explanation, and then bam, the picture. What about the intercepts? That should be easy.
2, 0, negative 3, 0.
Yeah, 2, 0.
Negative 3, 0, and 0, 0.
Yeah, negative 3, 0, and 0, 0. Now be a little more specific. This, of course, are the x-intercepts. So, of course, we need a y-intercept. But in this case, it just happens to be
0, 0.
already listed as 0, 0. I like it. Anytime you go through the origin, it's going to be an x and y intercept, and you can only have one y-intercept, or else it's not even a freaking function then, right? Wouldn't pass the vertical line test. Okay, cool. How are we doing so far? Good? Blah, 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 blah. What's the behavior at each of these? And why? What does it do at 2, 0?
That goes through.
Through 1.
Again, it's multiplicity.
Good. Multiplicity is 1. What about at negative 3, 0?
Turns.
Turns, because the multiplicity is even. Is that cool? I mean, at around -3, it should be parabolic. It should turn there. So it's going to, the behavior at the roots will mimic the behavior of what it looks like near the root. So near that -3, it looks like a square, it looks like a parabola, so it's going to turn. At each of these, it looks like a straight line. It's going to go straight through. Not straight, it's going to go through. So of course, at 0, 0, it's the first power, so it's going to go through. Because the multiplicity is 1. Let me just stop right there. Do you guys understand what I just said? Yes?
The one that you have -3 and 0, how is it multiplicity 2?
Where did the -3 come from? What piece of the equation? Yeah, that part. And what's the power on that part? There you go. That's it. How many? Multiplicity really means how often does this factor show up? It shows up twice.
So it's not to be n minus, that's something else, okay.
Yeah, no, that's something else. Good. That's how many turning points it might have total, I think is what you're thinking. Yeah.
Just a quick amplifying question on the multiplicities. So I know with evens it turns, with odds it goes through. But just so if the multiplicity is singular, if it just x minus 2 as compared to like x minus 2 cubed, does that mean that if it's singular it will just go straight through, or if it's cubed it'll make a little turn there, like a little divot there?
So this function in no place will this function be straight. Because it's not a linear function. And what's really weird is if I zoom in on something like x plus 3 squared by itself, if I zoom in on that parabola, at any point I zoom in, if I zoom in enough, it's going to look like a straight line. It's going to look like a straight line. Sort of like the Earth for a lot was thought to be flat. It's just because it couldn't get far enough away to see, oh yeah, it's rounded.
Yeah, basically, because in that you were saying before that in the section where it's squared, it's going to mimic parabolic behavior.
Now I'll tell you this, I think what you're saying,
is it going to mimic linear behavior?
if it was a cube, you're right, it could do something like this. Whereas if it's linear, it's not going to do that. It's going to go, it's going to like curve, but it's going to go straight.
Yeah.
There's not going to be any of that little hesitation yet. Good, okay, that's good. Okay, let's see, blah, blah, blah. And then the last thing here is, of course, to graph this thing. So if you just plot actually, let me do this. Instead of recreating, let me just go ahead and give you the answer. Make sure that looks all right.
So for the minor stuff, would you just set it equal to 0? Or how
Set x equal to 0, yeah. And just because there's an x factor, it's going to end up being 0. If you set x to 0, that first x kills the whole thing.
You can also get just like factoring it out, right?
Yeah, if you multiply it out.
Yeah.
Yeah.
Oh yeah.
Don't do that.
Factor it out.
Oh, I lost count here. Let's see this. Real quick, while you guys are looking that over, Chaz. See you coming? No Chaz. Helen. One. And Tasha. Oh. So the one we're looking at was number 3. I'll be really careful. Again, I think I said this the first time I passed out that first practice test answer key. Don't just agree with me. It won't do anything for you at all. It's like you're not really even studying. So give it a try, check it out. If you make a mistake, maybe try it one more time. Don't over try these practice test problems, because then you get way too familiar with that specific problem. And I am not going to give you that specific problem. So you got to know how to handle that kind of problem. Now, number 11 is an example of one of those rational functions with a slant asymptote. Of course, if you don't look at it, can you tell me what tells you you're going to have a slant asymptote?
X squared on the bottom over that is.
It's bigger than the bottom.
Yeah, it's a comparison thing, right? If the top power is bigger than the bottom, it's going to go to infinity and negative infinity maybe, but in a certain way. Or, either or, depending on the end behavior. And that's that slant. That's what the slant says. You're going to go to infinity this way. You're going to look like this. And you could have, the top could be a fifth power and the bottom could be a cube. And when you divide those, you should end up with a squared. And that's beyond what we do. I think the book has an example like this where you can have parabolic slant asymptote, right?
So it's like.
Yeah, so it's got to do some weird, it could do weird stuff in the middle, but in the end it's got to go up and match that parabola. So you could have vertical asymptotes in the middle, all this weird shit, but at the ends, it's got to match that parabola. Cool. I'm just going to give you at most a line for slant asymptote, just like number 11. "12 is an example sort of like the one we did earlier, where we had to look in the calculator. The one that's still up here, this evilness here. But that function's a lot easier to look at. So that's the function from number 12 for the volume. Oh yeah, so it freaks out. Should I put it in there? Yeah. So now it should have a 0 at 0, but it also has a 0 at plus or minus square root of 600. So it's, I don't know if you guys see that. If you factor this thing, right? Let's see if we know anything else here. So if we try again, if you do this and you can't see your function, there's a couple things you can do. I can look at my table and get an idea for where this thing is. So at 0, it is at 0, but then at 1, it's at almost 600. So, shit, I'm not going to see this thing. And it goes pretty high up from there. And at some point, there it is. It starts turning back around. Okay, Jeff, you want to look right there. There we go, around here. And you can see that the answer I got was 14.14 on the answer key. And 14 is right about the highest point, and then it starts to come back down. So right in between 14 and 15 is where it turns. So can anybody tell me what I should make my window so I can see that? So the table, I know we've looked at it just a couple times, but it's a really cool place to go to figure out where the hell is my function to help me set my windows. I know it goes up how far? 56. So I can make what would I change to what? To make sure I can see it. Yeah, let's make it 6,000 just to be crazy. So I can make Y max 6,000. And of course that was occurring out there around 14. So I want to make X max 20. I love it. There we go. So right? You don't have to make sound effects. So then how do I find that max point? second calc, and then amazingly enough, is the one called maximum. And they ask you those three questions like you did before: the left side, the right side, and my guess. And there's where I get the 14.14. So if I don't say, or if you're in doubt, you can round to a couple decimal places, round to the hundreds place. If I want more, I'll be specific. How did I get the 28.28?
You divide the y by.
Well, I have an equation that says y equals 600 minus x squared. I can just plug that x value in to that equation and get what y is, right? You guys see that? Okay. So that's how you do it on the calculator. Hopefully by hand you can get to the point where you get that function to graph. So if you end up with a function that's like all negative, like I was looking at earlier, but this one I actually did want to find the maximum, but just come up and ask me what the hell went wrong. Most of the times it's something, some button got pressed that you didn't need to press or something. I don't want that to be the reason why you're getting all freaked out. All right, and I know some of you guys, when you take a test, for some reason you have to do number 1 and then number 2 and then number 3. Is anybody like that wants to admit that? I had a friend of mine that sat next to me once in my grad class, and she had to do it that way. It's just crazy. You have to do whatever you can first and then come back. So I don't want you to get stuck somewhere thinking, I can't even do this problem. Just come up and ask me what's going on, or let it go. Go to the next one. Any other questions on the practice test or the homework?
Can you go over find the asymptotes?
Yeah. Didn't catch it. Yeah. So the vertical asymptotes will always come from where?
From values x can't be.
Good. Comes from the domain. It comes from restrictions on domain. Right. Now some of those restrictions might not be vertical asymptotes. They might just be dots, open circles. I like it. That's the last question on the practice test. What happens when your vertical asymptote little factor actually cancels? It'll just be an open circle. So that's why I say it comes from this. But in general, if I have, then my vertical asymptotes will be where? 3 and negative 7, because those are the things that can't be. So that would be my vertical asymptotes. Right. Horizontal asymptotes, how many situations are there? 3. One of them is here, when the bottom power is bigger than the top. And it's all on that handout I gave you. Hopefully you have it. Well, when the bottom power is bigger than the top power. And British Petroleum is bigger than TV. Then what happens? That means the bottom is getting bigger quicker than the tops. And obviously the top ain't going anywhere in this case, right? So that means the whole thing's going to go to 0. So this would be the horizontal asymptote here would be y equals 0. If they're equal to each other, when the top power equals the bottom power, what happens? If I let x equal 0, all I'm going to do is find my y-intercept when I do that. To find the asymptote, if they're the same, I just find the ratio. Exactly. That's 1/5. You guys see that? 1 to 5. And again, the hand waving way, that works perfectly. There's not a damn thing wrong with it, but still, it's looked down upon. When x gets really, really freaking big, these other pieces don't mean crap. They go away, basically. These things are so huge that those don't really affect it that much, so overall it's going towards 1/5. That's the whole thing when we divide by the highest power. We're actually basically doing that. We're seeing who would be left alive, which pieces basically go away. That's all that does. It makes it look more rigorous. And of course the last situation, the only one we haven't done yet, is at the bottom is smaller. Now be a slant. And how do I find that slant asymptote? You do long division. I love it. You can actually find this by long division also. Because if you do 5x to the 4th, blah, blah, into 1x to the 4th, blah, 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 into blah, blah, blah. What would you have to put here to make this even start? 1/5. And then you'll have a remainder term, blah, blah, over 5x to the 4th, blah, blah. That's going to go to 0. That's why it's 1/5. That's actually a shortcut itself. If you did the long division, that's the constant term you would get. So why do the long division when it's just going to be the ratio of those things? Hopefully. There's always more than one way to see why something works. Because if it works, there has to be more than one way to look at it. There must be some other way to come at it. Okay, so long division to find this dude. That's like number 11. And the other example, I just don't have an example like this. Because I figured 2 is enough. Right? I'm going to give you one rational problem that you have to graph. And I might ask you 1 or 2 other ones that you don't have to graph. You just have to answer me something real quick. So you can imagine what I would probably do. And if you can't, you'll find out. So anything else from homework or the practice test? Oh yeah. If I gave a problem like this and I wasn't sure what to even try, one thing is you're going to have the graphing calculator. So I hope if you graphed something and you got, then I would think an upper bound good candidate would be 4. Because there's no more intercepts after that. And a lower bound good candidate would be -5. You kind of see what I'm saying? Just to get an idea. But even if I didn't let you use it, I would use something like 20. I would use something big and -20, just to kind of be sure that I'm in a place. All I'm asking you to show me. On the answer key I gave 2, and I can't remember now how I figured out. Which one was this number? 5. I used 4 and -3. And to tell you honestly, it's like a year ago I did this, because that was actually for my Math 176, so it's still up there. So I probably graphed it and then just saw what was going on and then tried those. Right? On the test, I might ask you, show that 8 is an upper bound. What would that mean? To be an upper bound, what has to happen?
Just long divided by 8, and then it would.
You don't mean long, you mean synthetically divide, and you should end up with a row of positive numbers. Like to be a lower bound, you have to end up with a row that alternates every step. If you get any zeros in it, they can be considered positive or negative. You with me? So if I saw this is where it gets a little freaky. If I divided and I saw 1, 0, 1, -2, 5. Is that either kind? Is it an upper bound?
No.
Hell no, it's got a negative in there. All right, that's out. Is it a lower bound?
Yes.
Yes. Positive. I can consider that negative. Positive, negative, positive. That alternates. That's what I mean by 0 is positive or negative.
Kind of fits what you want it to be.
Exactly. And to me, the really weird thing is, if I had this actually, this happens. Is that an upper or a lower bound? It's lower. That's true. And it's upper, right? It's positive, 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 positive. as positive, negative, positive, negative, positive.
So does that just mean the only zero is zero?
The only zero would be whatever the hell I divided by to get there. The only real zero, the rest of them would be complex. That's neat when it happens. And you can see that's why zero can be either one, because sometimes it actually has to be both to make sense of what's going on. I probably do one that didn't have a zero because I don't want that to freak you out, but that's how zeros work in that bounds situation. Okay.
You do number 9.
Oh yeah. Oh yeah. So what's the what's standard form mean for a parabola?
X minus h plus
Who, what?
a times x minus
A
plus k.
plus K, 11. HK, they like to use that for vertices and for centers of circles and things. Okay, and really you can see it's just the transformations, right? And the A is just going to be positive, negative, up or down. If it's a big number, it's skinny. If it's a small number, it's fat. Smaller than 1. So I give you this function. Right? And then I ask you to put it in that form. Now the big thing to realize is, dear God, there's no need to do this to yourself. What have I done wrong? Well, I've done 2 things wrong. That's better, Jeff. What have I done wrong?
3.
Now, I need to take out a 3.
You took that, you added that, you included the constant.
Yeah, I don't need to put that in. In fact, I need that spot to be blank, right? To do the completing the square step. I need this spot to be blank. So thank God I can just leave the 2 nice and whole and out there. So now, what number has to go here to make this work?
9.
Exactly half of negative 6 is negative 3, and then negative 3 squared is 9. That's the steps to take to tell whatever has to go there. So if you add 9 here,
Subtract 27.
I actually just added 27, so I have to subtract 27. Do you guys see that? I can't just do this. Because if I multiply this out, it's not going to come out to be the same thing anymore. What I actually just did was I added 27. So I better subtract 27. And what I see some people doing on their in their homework is beautiful. Minus whatever the hell you just put there times whatever the hell's out there. And that's beautiful, because obviously it gets you to the right place. You can always do that for this. That's what you subtract. So you end up with, how does this thing factor?
X minus
Always like that first step.
X minus 3 squared.
Good. X minus 3 squared minus 25. Okay, so you know I'm going to give you a question like that. And you know it's probably not going to have a 1 there. So you know you got to be able to do this kind of thing. Right? Can't be more direct than that. So the vertex there would be what?
3 negative 25.
3 negative 25. And what's the shortcut to get the vertex?
Negative b over 2.
Negative b over 2a. So if I do negative b over 2a, what's b? Negative 18. And what's a?
9 or 6.
3. You get 6.
Yeah.
So 18 divided by 6.
3.
3. Thank God. So that matches there. And then if I plug a 3 back in, I'm going to get negative 25. That's how I can verify. So normally, if I don't ask you to put it in standard form, if I just want you to find the vertex, dear God, don't do this. Right? It's nice if you do it, but don't do more work than you have to. Just do the shortcut. Okay, cool. Any other questions from homework or practice test?
40.3.6.
3.6 number
40.
40. Oh yeah. So they want me to find a polynomial. So this is number 43.6. It says find a polynomial q of x where 4. It's degree 3 and it's got zeros, -3. And you can do it, Jeff. 1 plus I. So it's degree 3. Alright, so there's two things that tell you what you have to augment this with. The first thing tells you something must be missing because it's degree 3, but they only list 2 roots, and they know there's got to be 3. And the other thing that tells you, so you know something's missing, and then you also know that anytime you see a complex answer, what else has to be there?
Square root of -1, so it's negation.
It's conjugated, right? As long as the original polynomial has real coefficients, then the only way that the imaginary stuff goes away is if its conjugate is in there also, right? So when you multiply those, they become real. So what's missing?
1 minus I.
1 minus I. So now, how do I write this?
X plus 3.
Good. X plus 3 would have a 0 of -3.
X minus.
Good. X minus 1 plus I would have a 0 of 1 plus I.
1 minus.
Keep going, yeah. X minus 1 minus I. Because again, where did the plus 3 come from? X minus -3 is. See, that's the general idea. If something has roots A, B, and C, then that would be X minus A, X minus B, X minus C. It's just that we forget that when we put X plus 3, we don't even realize what we're doing. And we're like, what the hell do I do with this? I always get somebody to do X plus that, X plus, that doesn't make any sense. It doesn't really follow. And then just multiply out, and this is out here. Now here, the thing is, I would leave it like this. Because when I multiply this out, I'll get x squared. Oh, I can even make it a little nicer. What you got for me? Minus 1 minus I, x. Minus 1 plus I, x. And then here, this is going to be like a difference of squares. You see that? Minus minus is plus 1 minus I squared, so 1 plus 1 is 2. Okay, I don't know if you're going to see that or not, but it's just foiling. You guys can do that. Do you have to do that weirdness? No, you could take these parentheses, bring the negative through, and then you could do the triple, x, and bring the 1 through, and then bring the I through. That's nothing wrong with that. This way it just gets there a little quicker. What do we get here? We get minus x, so minus 2x, plus ix, minus ix, the i's went away, plus 2. And then FOIL that out. Get your polynomial at the end. So you know I'm going to have a problem like that where I give you at least one complex number, so you have to put the conjugate in there too.
Can you use 69 from 3-1?
Oh yeah. So it's a long setup, but they get you there. And to tell you honestly, if any of you guys are going to take Math 178, anybody going to take Math 178? No? No 178ers?
That's business stuff, right?
Yeah.
They already did it.
You took it already? Oh man, if you would have done it the other way around, it would have been easier. But you did a lot of, doesn't it sound familiar? Yeah, okay. But apparently it doesn't matter. Nobody has to worry. So they give you the equation that I've already forgotten.
What question is this?
This is number
69.
section 3.1. So they tell you the number of apples produced by each tree depends on how densely the trees are planted. If you put n trees on an acre of land, then each tree produces 900 minus 9 n apples. So if you put another tree, it's going to be 900 minus 9 times 1. It's going to be a few less apples because it's got the nutrients have to be given to the other tree too and all this kind of business, right? Right, unless you have one big ass tree. Survival of, no, let's not bring that up. So they're all equally Darwinian diseases, they're all going to be fine. So they gave me the function that I have to work with. This is the number of apples I can expect given this many trees have been planted. And they asked me to figure out what's the, how many trees should be planted to obtain the maximum yield of apples. So what do I need to do with this function? Find the maximum. And what kind of function will it end up being? Parabolic, quadratic. Right? So that's exactly the kind you can do by hand. How do you find that maximum here? Why will it have a maximum, first off?
Parabolic and negative.
Beautiful, I love it. It's a negative parabola. So it's going to face down, so it's going to have a maximum point, top of the hill. How do you find that really quickly?
Negative 900 over negative over 2.
In general, negative b over 2a. Here I'm just using n instead of x because I have n's in there. Right? Kind of makes sense. So negative b, what's b? 900, good. The thing in front of the first power term. Negative 900 divided by twice negative 9. And that's who? 50. I love it. And what the hell does that mean? 50 what? Trees. So if I plant 50 trees per acre, right? Yep. And they just asked me how many trees should be planted. But how many apples would I expect? How would you figure that out?
Plug in 50.
Yeah, plug 50 in. Number of apples for 50 trees. Just plug a 50 in. Who the hell that is? I don't know. Whatever 450 times 50 is. $22,500 or something. Yeah.
22,500.
Okay. Yeah. That's a lot of apples. Julie makes them. All right. And if at any time you are ready, you do not have to stay here. Right? So I don't want you looking at me like, stop talking. If you are ready for the test, you don't have to stay here. But if you have any questions, the floor is open. It's yours. Anything else you want to look at that we haven't looked at yet? What have we left out? We've done just about everything. We have the complex numbers, which hopefully you guys are pretty cool with. In fact, that section should have been like a breath of fresh air in the middle of all this weird graphing stuff, right? Yes, thank God, it's complex numbers. Got the rational stuff. Number 4 was use your calculator to find the maximum minima. We did a problem like that there. So whatever function I give you, you just have to be able to find the max and minis. Inverses, we talked about inverses already. Nobody asked about Descartes' rule of signs, so I guess that's okay. You guys have to know that for the test, right? That didn't spur any questions, so I'll keep going. And you know how to find all the possible rational roots, like the number 6, right? You guys are funny. You know, like, I don't want to be the first one to get up. Yeah. Any other questions? We don't have to stare at each other. Well, I'm desperately wanting to help you out if you have something you want to look at. But if you don't, yes?
Practice rule again.
Say again?
Descartes' rule again, for science.
Oh, Descartes? I like it. Made him sound of a different culture. Descartes. Hey, Descartes. I'm here. Just showing you back. Oh, so Descartes. So looking at the one practice test before. It was, and I'll show you something to be really, really careful about that happens a lot. That'll mess you up on the later parts of the problem. So, Descartes looks at the original function the way it is. What's Descartes, what's that rule really trying to get at? It's trying to tell me what?
The number of roots.
Number of real roots. I like it. Right? Number of real roots versus complex roots. And that's why they always go down by 2, because if it's not real, it has to be too complex. With me. So if I look at the polynomial the way it is, and I look at what now? Good. So I see 1, 2, 3. What does it tell me about the positive real roots? Yeah, it's going to be 3 or 1.
Why would it be like 3 or 1?
Because either there's 3. So let me see. I like it. Either there's 3 or there's 1. All right, no. Either there's 3, which means I have something like this. Right. So there's, in fact, and this is positive, so we'll say that. Right. So there's 3. Or I could have something I can't even factor that wouldn't even be real if I did factor it. Something like that. That would have complex answers. So there's either 3 positive real roots, or there's 1 because the other 2 would have to come from something I couldn't even reduce. It would be complex. Does that make sense?
Yes.
All right, good. That's why it's got to go by 2, because complex answers always have to show up in pairs. So if I have 3 real roots, now I can't have 2 positive real roots because I can't just have 1 complex one by itself. So it's always going to go down by 2. Cool. Now how do I look at the negative?
P of negative x.
Yeah, look at P of negative x. What's going to change signs? The odd ones are going to change signs because those are not going to kill the negative when I plug it in. So you get negative 2x5, this one stays, this one changes, this one stays, this, I think we get it, Jeff. Okay. So how many changes of sign do I see there? Yeah, 1, 2. So what's it tell me about negative real roots? 2 or 0. Good, 2 or 0. Now this is a very fine point. What list do you guys make when you look at the last and the first one? You make the list of the possible, be more expansive, possible rational roots. The only ones we can find by factoring directly is rational roots. This talks about real roots, and they can look as ugly as they want to. It could be the 1 plus or minus square root of 11 divided by 48. I mean, that's nothing I would get by hand easily factored. You with me? I don't even know if you guys realize there's a distinction there to be careful about. Just because there's definitely going to be 1 real root, it might not be something I can get synthetically. I am not going to synthetically divide by 1 plus square root of 11. I'm not going to do that. And if I'm not going to do it, you're probably not going to want to do it either. Right? That's just insane. I'm not going to do that crap. I'm going to synthetically divide by rational numbers. Alright, it's enough of that. I don't think you guys see the point of it. There's a distinction between what this tells me and what's going to happen, what I'm going to see from my list. There might be no negative real roots, so when I synthetically divide, I'm probably going to go with the odds and divide by the positive ones first. Because there's a slightly higher chance I'm going to find something. Now, here's the mistake people make. When they go on to the rest of the problem, they start looking at this guy instead of that guy. And this, the usefulness of this is only for that. suddenly they start treating that like the function I gave them, and that just so sucks when it happens, because then everything's kind of like reversed in some weird way, right? So be very careful. That's your function you're working with. That was just for right then, just to see the negative roots. Yeah.
So if there is no sign change, that means there wasn't any.
I love it. See, now that's where Descartes really kicks ass. If it doesn't change any signs, that means there's no positive roots, or if you're looking at the negative and there's no negative roots, then your list, however big your list is, gets cut in half. See, that's when Descartes really kicks ass. Most of the time, it's kind of like, all right, Descartes, you helped my odds out, but shit. Something down about it, by the way. That took a lot just to get here. Can you imagine trying to come up with this on your own? Didn't exist. You proved it. I mean, that's crazy. But still, it's not terribly useful a lot of the time. Yeah.
Can you explain why it would be 0, maybe?
Say again?
Why would it be 2 or 0, maybe?
Oh, because, again, I could have a quadratic piece like this that I can factorize. It comes out to real numbers. Or it could be like this, where it would have complex answers. And if I know that there's 2 negative roots, if they're not real, they both have to be complex, because they have to have 2 complex answers that go together, right? That's why these always go down by 2. If one of them's not real, then actually 2 of them aren't real, because you need 2 complex numbers to go together. That's why these always go down by 2. So if I saw 8 changes in sign, you would say there's 8 or 6 or 4 or 2 or 0, right? Yes?
You just said that if there were no changes, then there wouldn't be any, but didn't you say if there's no changes, then it'd be at most n positive roots, then n minus 2 and n minus 2?
No, those are turning points. Are you talking about turning points, or are you talking about...
Yeah, it's just something we wrote down in Descartes' rule of signs. If P of x has like n sign changes, like none.
N, meaning like 9 sign changes, 8 sign changes. Yeah. But if it has 0 sign changes, there's nowhere to go from 0, right? So if it had 1 sign change, it's 1, because you can't subtract 2 from that. If it has 0 sign changes, it's 0, you can't subtract 2 from that. That's when Descartes becomes really useful, when he cuts half of your list off. Yeah.
And with Descartes' rule, the only thing that it tells us is that there will be either 3 or 1 positive. Like how can we shorten the problem?
That won't help you shorten the problem. That's what I'm trying to say. It would only help you shorten the problem if this would have all come out negative. Then there would have been no negative roots. So you would have, your list would look like plus or minus 1, 2, 3, 5, 7, whatever. You can cut out all the negative ones then. You don't have to try any negative ones in your synthetic division, because Descartes would have said there aren't any. But when it's like this ambiguity, it doesn't really help me out. In fact, that 1 positive root might be a freaky one that I would get from some other way. Like 2 of these might be from quadratic formula. I'm not going to do that with my synthetic division. I'm going to use whole numbers, or at worst, fractions in my synthetic division.
So trial and error.
Yeah. At that point, it doesn't really help me.
For number 7B, I.
Oh yeah. So remember, if it's why is this problem here really nice? Because 4 goes into 44 evenly. So remember, every 4th one goes back to 1. So if I am at 47, that means I am 3 beyond being 1. So I'm 1, 2, 3. I'm right there. This would be negative I. So if I look, how many times does 4 go into it? What's the remainder? The remainder here is 3. So this is equal to I cubed. Because look, I can rewrite this as I 44 times I cubed, right? Is that cool? And that's really what I did on the paper, on the answer key. This, of course, is 1. So I just have to know what I cubed is. So you have to memorize these 4 basic ones. First one's easy. So the paper I did I-411. Well, 411, if only was 408, 4 would go in, and that leaves 3 extra, right? Since this is I to the 4th to the 102nd power, this is going to be 1. So I'm left with I cubed, which is negative I. But you can eliminate all that crap and just say 3 goes into 411, blah, 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 remainder 3. It doesn't even matter how many times it goes in, because that piece is going to be 1. The important thing is, what's the remainder? That tells me where I am in the cycle. Remainder 1, 2, 3, there I am. So if you know these 4 basic values, you could do I to any power. What's the most important power to know? I squared, because that shows up when you FOIL and when you divide, you got to multiply the conjugate, you got to multiply it out. When you get I squares, you got to replace it with negative 1. So that's really the most important, useful one to know. Okay. Any other questions?
Are you gonna have office hours today?
Yeah, like going, meeting right after class and then right before my later class.